all of the algebra we've been looking at so far has been leading up to trying to solve equations. And certainly in high school you spend the first couple of years looking only at one type of equation, a linear equation. We're going to look at linear equations and also a couple of other, but we're going to start with linear equations. There's a golden rule for solving linear equations, and that is to do the same thing to both sides with the goal of isolating the variable. I mean, really, what it is you're trying to do with an equation is find all values of the unknown, the variable, that make the statement true. And I've put instructions beside all these equations. Every time you're solving an equation, the instruction will be to solve. Prior to this, we've been doing things like simplifying algebraic expressions, but we haven't been solving for anything. So here we're actually going to solve. We're going to try to find the value of x that makes the statement true. Now, certainly for the first few, you don't need any rules of algebra to be able to solve these equations. You can just look at them and figure them out via arithmetic or intuition, and that's perfectly fine. If the equation is simple enough, you should do that. It's usually faster. If you have to resort to using all the rules of algebra, it's probably going to take you a little bit longer, but it's nice to have that kind of machinery to be able to pull it out and solve equations when you really want to make sure that you actually get the right answer. So this first one here, 5 plus x equals 8. Again, the goal is to get down to a statement that just has x. So what we're going to do is we're going to somehow get rid of that 5 on the left-hand side. And the way we do that is just simply by subtracting 5 from both sides. So we have the 5 there already. We're going to subtract a 5 from the left, and therefore we have to subtract a 5 from the right. So we're doing the same thing here to both sides, and that preserves the equality. On the left-hand side, 5 minus 5 is 0. It disappears. There's no need to write it anymore, and so we're just left with x. We've isolated the variable, which is the goal. On the right-hand side, we simplify that. 8 minus 5 is 3. Now, the nice thing about solving equations is that you can always check to see if they are correct just by taking that value of x, plugging it back into the original equation, and seeing whether it's a true statement. So here's our check. 5 plus 3 equals 8, and that's true. So we've solved this equation. Alright, so in that particular case, we subtracted the same thing from both sides to isolate x. Let's try this again for the next equation. 12 equals x minus 5. So again, we want to isolate x. X happens to be on the right-hand side of the equation. That's not a big deal. It doesn't really matter whether you end up with x on the right or the left, as long as it's isolated. So how do we get x on its own? Well, in this case, we need to do the opposite of subtracting 5, which is adding 5. So we're going to add 5 to both sides. There's the adding 5, the operation we're doing to both sides, exactly the same. So we've preserved the equality. On the right-hand side, minus 5 plus 5 is 0. It disappears. We're just left with x. And then 12 plus 5 is 17. And again, we can check this. If you're ever in doubt, you should always check. So we have 17 minus 5, which is 12, and that's a true statement. So we've solved the equation. Let's take a look at an equation where the variable has a coefficient. So 2x equals 10. So now, in order to get the variable isolated, in other words, to get just x on its own, we need to somehow strip off this coefficient too. So again, it's helpful to ask yourself, what's being done to x? And what's the opposite of that action? So here, having a coefficient of 2 means you're multiplying x by 2. The opposite of that would be to divide x by 2. Or alternatively, you can think of multiplying x by a half with the goal of getting a coefficient of 1. Remember, if there's a coefficient of 1, we don't write it in, we just write the variable x. So let's use division. So we're going to divide the left-hand side by 2, so we have to divide the right-hand side by 2. There's the operation you're doing to both sides. On the left-hand side, you end up with x all on its own. On the right hand side, you simplify that expression. 10 over 2 is 5. And of course you can always check. 2 times 5 equals 10. That's true, so we've solved that equation. Let's try that one more time. On the right hand side we have negative 3x. We're multiplying x by negative 3, so we need to do the opposite of this. We need to divide by the coefficient, negative 3. And we need to do the same thing to both sides. So we end up with x on its own on the right hand side, and there's really not much we can do with the left hand side. It's not an integer. I don't think it's worth putting it into a mixed fraction form. I don't think mixed fraction forms are any easier to deal with than common fractions. So negative 5 over 3 is the answer. The solution to equations is not always going to be an integer. In this case, it's negative 5 over 3. We can certainly check the answer here. 5 is equal to negative 3 times negative 5 over 3. The negative times a negative makes a positive. The 3 over 3, common factor, numerator and denominator. Remember, negative 3 can be thought of as negative 3 over 1 if you forget how to multiply an integer and a fraction. So the 3's cancel, the negative signs cancel, and we end up with a true statement. Now, just an aside here, some people get a little bit confused when you have negatives and fractions. Negative 5 over 3, which is the way I wrote the solution to this, is the same as 5 over negative 3, which was in the previous line, which is the same as negative 5 over positive 3. Remember, a positive divided by a negative, or a negative divided by a positive, these are both negative numbers. And the simplest or best way really to write this number is simply negative 5 over 3. But the other two are equivalent. Alright, let's take a look at one more of those. 3x plus 5 equals 9. Alright, so now we have both a coefficient and we have something that we're adding. And there's two steps we're going to have to take. The order of the steps, in some senses, doesn't really matter, but in other senses, one way will make life a little bit easier than the other. It's usually easier to isolate the variable expression first and then worry about the coefficient. So to isolate the variable expression, 3x, we need to get rid of that plus 5. And we do that by subtracting 5 from both sides. So we have plus 5 minus 5 equals 9 minus 5. So we're doing the same thing to both sides. And we isolate not the variable x, but the expression 3x. 9 minus 5 on the right is 4. Now we can divide both sides by 3, and we get 3x over 3 equals 4 over 3. I'll just move this down a little bit. And finally we have x on its own. And again, the answer or solution here is not an integer. It's 4 over 3. That's fine. We can still check this. It just takes a little bit more time to check. 3 times 4 over 3 plus 5 equals 9. May not be immediately obvious that it's true, but if you cancel the 3's, you see it's really 4 plus 5 equals 9, and that is indeed true. Alright, one more involving the distributive law. So we have 2 times 5x minus 3 equals 9. There's almost always some flexibility in how you solve equations. I would suggest for this one, keep things in integer form first, which means just simplify or expand the expression on the left. So if we use the distributive law, which we learned a couple lessons ago, we can multiply the 2 by both of those expressions. We have 10x minus 6 equals 9. We then can, I need to extend this, we then can isolate the expression 10x. We're going to do that by adding 6 to both sides. So now we have 10x equals 15. And finally, we're going to divide both sides by 10. So 10x over 10 equals 15 over 10. So now we finally have x on its own. 15 over 10 is a fraction. It's not in simplified form though. You're looking for a common factor in the numerator and the denominator. That common factor is 5. When you take out the 5 from both the numerator and the denominator, you're left with 3 over 2. And I'm not going to check this for you, but you can certainly check this to see that this yields a true statement, and therefore we've solved the equation. One distinguishing feature of linear equations is that there is always one solution only. In a few special cases there's no solution, but you cannot have a linear equation where you have 2 solutions or 3 solutions, for example.